January 17, 1942. Essen, Germany. The Krupp steelworks. The furnaces roared like caged thunder in the pre-dawn darkness, casting shadows of molten orange across faces blackened with soot and exhaustion. Inside the cavernous factory hall, where Bismarck's cannons had once been born, German engineers moved with methodical precision around the skeleton of a 15 centimeters SFH-18 howitzer. Every weld was measured, every component inspected 3 times. The air tasted of coal, dust, and iron, and somewhere beyond the reinforced walls, the war machine of the Third Reich demanded more, always more. But here, in the birthplace of German industrial might, quality was religion. A single heavy gun took 47 days to complete, from the first pour of molten steel to the final test firing at the proving grounds. The engineers worked in shifts that bled into one another, their hands steady despite the tremors of fatigue, because they had been taught since childhood that German engineering was not merely superior, it was destiny made manifest in steel. Across the Atlantic, in a converted automobile factory outside Detroit, a different kind of forge was awakening. The night shift at the Chrysler tank arsenal had just ended, but the assembly line never stopped. It merely changed hands. Where German craftsmen gathered around individual gun carriages like surgeons over patients, American workers, many of them women who 6 months earlier had never touched a wrench, moved in synchronized rhythm along a conveyor system that stretched the length of 3 football fields. Every 12 minutes, another 155 millimeters howitzer rolled off the line. Not inspected 3 times. Not cradled through 47 days of perfectionist labor. Built, tested, painted, and shipped before the metal had fully cooled. The factory floor smelled of machine oil and possibility, and the workers went home each evening knowing they had fed a beast that consumed artillery pieces the way a bonfire consumes kindling, voraciously, endlessly, and without apology. This was the arithmetic of annihilation that would reshape the world. The story begins not in 1942, but in the twilight years of the Weimar Republic, when German military planners gazed upon the humiliation of Versailles and began their patient, meticulous resurrection. The treaty had forbidden Germany from possessing heavy artillery, from maintaining substantial armament factories, from reclaiming the industrial pride that had made Krupp and Rheinmetall synonymous with military dominance. But the engineers remembered. In basement workshops and rural testing grounds disguised as agricultural facilities, they refined designs for weapons that existed only on paper. When Hitler tore the treaty to shreds in 1935, these phantoms became steel. The 10.5 centimeters LuFH-18, the 15 centimeters SFH-18, the fearsome 21 centimeters Morser. Each piece was a masterwork of ballistic engineering, capable of hurling high-explosive shells with accuracy that bordered on the supernatural. German artillery doctrine emphasized quality of fire over quantity, precision over saturation, because their entire military philosophy was built upon the concept of the decisive battle, the Kesselschlacht, where superior training, superior equipment, and superior will would shatter enemy formations in calculated strikes. The numbers reflected this philosophy with crystalline clarity. Between 1939 and 1945, German industry would produce approximately 68,000 artillery pieces of all calibers. Of these, fewer than 5,000 were heavy guns, the 15 centimeters and 21 centimeters pieces that represented the pinnacle of German ordnance engineering. Each gun was a monument to old-world craftsmanship, assembled by specialists who could trace their lineage in the steel trades back through generations. The Krupp works in Essen alone employed 23 different quality control inspectors for each production line, men whose sole purpose was to ensure that every tolerance met specifications measured in thousandths of an inch. When a German gun left the factory, it bore not just a serial number, but an implicit covenant. This weapon would perform exactly as designed under any conditions, from the frozen steppes of Russia to the desert furnace of North Africa. This was the strength of German artillery. It was also its doom. Across the ocean, America in 1940 possessed an army that ranked 17th in the world, smaller than Portugal's, equipped with artillery pieces that had last fired in anger during the Meuse-Argonne offensive of 1918. The industrial capacity existed. The same factories that had revolutionized automobile production could theoretically build anything, but the will remained dormant. Then came the fall of France. In 6 weeks, the Wehrmacht demonstrated that modern war consumed material at rates that defied peacetime imagination. The British Expeditionary Force abandoned nearly 700 artillery pieces at Dunkirk. France lost over 5,000 guns. The entire accumulated arsenal of a major European power, representing years of careful production, vanished in a single campaign season like morning frost under summer sun. President Roosevelt looked at these figures and understood with cold clarity that the coming war would not be won by craftsmen. It would be won by a different kind of craftsmanship, the mass production assembly line, the interchangeable part, the standardized design that sacrificed individual perfection for collective, overwhelming force. In January 1941, he announced the goal: America would become the arsenal of democracy, outproducing the combined industrial might of all Axis powers. The military planners received their mandate: design artillery that could be manufactured not by specialists but by ordinary workers with minimal training, built not in specialized armament factories but in converted automobile plants, shipped not as precision instruments but as rugged tools that would function adequately in the hands of adequately trained crews. The 155mm gun M1, which would become known simply as the Long Tom, embodied this philosophy. Its design deliberately incorporated loose tolerances. Components were made interchangeable not within batches, but across the entire production run. Where German guns required factory specialists to reassemble after transport, American guns could be field-stripped and rebuilt by crew members using only the tools carried in the gun's own kit. The barrel life was shorter than German equivalents. The precision at maximum range was measurably inferior. But none of this mattered because for every Long Tom that wore out or suffered damage, 3 more were already crossing the Atlantic. The American industrial machine had learned to build weapons the same way Ford built Model Ts, not as individual masterpieces, but as identical, reliable, infinitely replaceable components of a system. The German engineers who first examined capture American artillery in North Africa reacted with a mixture of professional disdain and bewilderment. The tolerances were loose. The finished work was crude. The sights were simplified to the point of being primitive by German standards. They build their guns, one Krupp engineer wrote in a report that eventually reached Berlin, the way we build our shovels. The assessment was meant as criticism. It became prophecy. By late 1942, the arithmetic had begun to tell its inexorable story. German factories, even when operating at maximum theoretical capacity, could produce perhaps 200 heavy artillery pieces per month. This assumed no disruption from Allied bombing, no shortage of skilled labor, no bottlenecks in specialty steel production. In reality, the Krupp Works, Rheinmetall, Skoda, and the other armament manufacturers struggled to maintain even this pace as RAF bombers began their systematic dismantling of the Ruhr industrial region. Each raid destroyed not just factories but something more precious: the accumulated expertise of master craftsmen, the specialized tooling that took months to replace, the fragile supply chains that delivered molybdenum steel from Sweden and tungsten from Portugal. German production became a desperate race to replace losses while simultaneously equipping new formations for the expanding fronts in Russia, North Africa, and eventually Italy. The heavy guns went first to elite units, the Grossdeutschland Division, the SS Panzer Corps, the Luftwaffe Field Divisions, while regular infantry divisions made do with captured Soviet pieces, obsolete French 75s, even horse-drawn artillery from the First World War pressed back into service. In America, the mathematics ran in the opposite direction, exponentially upward. By December 1942, American factories were producing more than 4,000 artillery pieces per month of all types. By mid-1943, this had increased to 6,000. The Chrysler tank arsenal alone, a single facility that had not existed before 1940, was producing more heavy artillery in 1 month than all of Germany's specialized armament factories combined. The numbers stopped being statistics and became something closer to geology, the slow, irresistible accumulation of material that buried everything beneath it. The factories ran 3 shifts. When skilled welders became scarce, training programs compressed years of apprenticeship into 8-week crash courses. When steel supplies tightened, priority systems funneled raw materials to artillery production, while consumer goods manufacturers converted their lines or closed entirely. An entire economy reoriented itself toward a single purpose: the production of overwhelming material superiority. The soldiers who would employ these weapons understood none of this industrial drama. They knew only what they could see: the endless convoys of trucks carrying identical crates, the artillery parks that stretched to the horizon, the casual abundance that made replacement barrels and fire control equipment available on demand rather than by allocation from some distant supply depot. An American artillery battalion in Italy or France carried more ammunition in its organic transport than an entire German division received in monthly allocation. When a barrel wore out after firing 10,000 rounds, half the lifespan of a German equivalent, the crew simply requisitioned a new one. The old barrel went to a depot where it might be relined, might be scrapped, might simply join the growing mountains of material that accumulated behind every advance like the shed skins of some great mechanized serpent. The German artillerymen, in contrast, learned to husband their weapons like medieval craftsmen caring for irreplaceable tools. Barrels were cleaned with devotion that bordered on ritual. Firing schedules were calculated to minimize wear. When a gun was damaged, specialized repair teams, former factory workers recalled to military service, would attempt repairs that American crews would simply have abandoned as not worth the effort. A German heavy gun was not just a weapon. It was a promise that could not be replaced, a fragment of industrial capacity too precious to lose. The battery commanders who managed these guns operated under constraints that would have been incomprehensible to their American counterparts, monthly shell allocations measured in hundreds rather than thousands, priority systems that reserve heavy artillery support for only the most critical situations, the constant awareness that every shot fired was a shot that might not be replaceable. This disparity manifested in doctrine with mathematical precision. American artillery developed the time-on-target technique, simultaneous impact from multiple batteries on a single point, coordinated through radio communication, and calculated using fire direction centers that treated ballistics as a problem of industrial logistics rather than individual gunner skill. A single fire mission might expend 500 rounds in 90 seconds, a storm of steel that transformed enemy positions into lunar landscapes. The effectiveness was less a function of accuracy, though American fire control steadily improved throughout the war, than of sheer volume. With enough shells falling in a target area, precision became superfluous. German artillery, conversely, refined techniques for achieving mission objectives with minimum expenditure. Single guns would fire carefully calculated interdiction missions. Battery salvos were reserved for targets whose destruction justified the irreplaceable ammunition. Precision was not a preference, but a survival necessity. The soldiers on the receiving end of these different philosophies experienced them as the difference between a surgeon's knife and a hammer. German artillery struck with calculated violence, shells arriving with disconcerting accuracy at crossroads, observation posts, assembly areas that German forward observers had marked for destruction. The fear was precise, personal, the knowledge that the enemy had seen you, calculated your position, and devoted irreplaceable resources to your elimination. American artillery, when it arrived, came as a natural disaster rather than a military operation. The forward observer called coordinates into his radio. Somewhere beyond sight, beyond hearing, beyond imagination, an industrial system absorbed the request and responded with assembly line efficiency. The shells arrived not in aimed salvos, but in overlapping waves, a rolling thunder that did not stop until the observer lifted the fire mission or the target area had been plowed into abstract geography. German veterans who survived encounters with American artillery spoke of it with a particular kind of awe, the recognition that they had faced something fundamentally different from traditional military force. A Panzer Lehr Division officer, interviewed after the Normandy campaign, described it as Materialschlacht raised to an almost metaphysical level, not a battle of material, but a battle in which material itself had become the strategy. The comparison was not to previous wars, but to natural phenomena, earthquakes, volcanic eruptions, forces that did not aim or intend, but simply overwhelmed through inexhaustible power. The psychological effect was cumulative and corrosive. German formations learned that concentration invited destruction, that movement attracted observation, that any activity within range of American artillery forward observers was potentially suicidal. Units fractured into smaller, more dispersed formations. Command and control degraded. The tempo of operations slowed to a crawl as commanders sought to avoid the attention of the endless American guns. The factories in Essen continued their careful work, each gun a masterpiece, each piece representing hundreds of hours of specialized labor. But the furnaces were going cold now, one by one, as Allied bombers returned with the same industrial persistence that characterized American artillery, not seeking perfection but simply returning, night after night, until the accumulated damage exceeded any possibility of repair. The Krupp works, which had survived every previous war intact, began to resemble a lunar landscape itself, craters and rubble where the great forges had stood. Production shifted to underground facilities, to dispersed workshops hidden in forests, to a desperate improvisation that could not replace what had been lost. By 1944, German heavy gun production had fallen to fewer than 100 pieces per month. By early 1945, it had effectively ceased. The American factories, meanwhile, had reached a kind of terrible maturity, their production systems refined to the point where artillery manufacture had become almost autonomic. The arsenal of democracy was producing 8,000 artillery pieces per month by late 1944, a figure that would have seemed like a typographical error to pre-war planners. These were not just guns for American forces, but for British, Canadian, French, Polish, Brazilian, and eventually Soviet armies, an ocean of material that flowed wherever it was needed with the casual abundance of water from an open hydrant. The long columns of American trucks carrying artillery forward had become a universal symbol of Allied advance, as characteristic of the Western Front as the Tiger tank was of German defense. But where the Tiger appeared in propaganda photographs because each one was precious and notable, the American guns appeared because they were everywhere, as common as rainfall. The symbolic weight of this disparity extended far beyond military effectiveness. German soldiers, raised in a culture that venerated craftsmanship and quality, that took pride in producing fewer but superior products, faced a cognitive dissonance that no amount of propaganda could fully bridge. The Nazi ideology had promised them superiority through will and racial destiny. The reality they encountered was superiority through manufacturing capacity and industrial organization, a profoundly unromantic, distinctly democratic form of power that made individual excellence irrelevant. A single German gun crew might indeed be more skilled, better trained, more dedicated than their American counterparts. But what did skill matter when 10 American guns responded to every German shot? What did training achieve when American replacement crews arrived fresh from depots, while German crews fought until they were destroyed? The American soldiers, for their part, absorbed a different lesson. They learned that democracy, whatever its flaws and compromises, could mobilize industrial capacity in ways that authoritarian efficiency could not match. The endless artillery was not just military support, it was a promise that the vast productive resources of an entire continent stood behind them, that they were not expected to fight with inadequate tools or make do with shortages. When they called for fire support, it arrived not as a carefully rationed gift from above, but as a right, an expectation that reflected the fundamental American belief that problems could be solved through material abundance and industrial organization. The artillery became a physical manifestation of a different kind of society, one that mass-produced not just guns but the very concept of overwhelming force made possible through voluntary cooperation rather than coerced efficiency. By the winter of 1945, the comparison had become almost obscene. German artillery units were fighting with whatever pieces they could salvage, repair, or capture. American artillery parks in France resembled industrial warehouses, thousands of guns arranged in geometric rows, more firepower sitting idle awaiting deployment than the entire German army possessed. The final offensive into Germany became an exercise in material demonstration, not because American commanders were particularly brilliant or German defenders particularly inept, but because the arithmetic had become so lopsided that skill and courage became rounding errors in equations dominated by supply tonnage and replacement rates. The last German heavy gun rolled out of a makeshift workshop in Bavaria in March 1945, assembled from scavenged parts by elderly workers who remembered building naval artillery for the Kaiser. It was never fired in combat. The crew assigned to man it surrendered to American forces 6 days later, the gun still in its transport position, a museum piece before it had ever become a weapon. The American artillery that accepted their surrender had been manufactured 4 months earlier in Pennsylvania, one of 847 identical pieces produced that month, shipped across the Atlantic in convoys so large they stretched over horizons, and distributed to units with the casual efficiency of mail delivery. The German gun bore a brass plate inscribed with the names of the craftsmen who had built it, a final gesture toward the old traditions. The American gun bore serial numbers stamped by machine, unreadable under the coating of mud and cosmoline, anonymous and perfectly interchangeable with thousands of others. In the end, the 5,000 German heavy guns, each a masterwork, each representing the pinnacle of traditional armament engineering, were buried beneath the sheer accumulated weight of 250,000 American artillery pieces. Not defeated in any simple tactical sense, but rendered irrelevant by an industrial capacity that had learned to treat war as a problem of production rather than perfection, of volume rather than virtue. The German engineers had forged weapons worthy of Vulcan's own forge, and America had responded by building factories that made Vulcan himself obsolete. The ruined Krupp works in Essen stand today, as a museum, the great furnaces preserved but cold, monuments to a particular kind of industrial pride that the modern world has largely forgotten. Visitors walk through halls where the SFH-18 howitzers once took shape, where craftsmen spent weeks on single components, where quality was measured not in production rates, but in perfection of execution. The tours emphasize the technical achievement, the engineering excellence, the traditions of German industrial might. They rarely mention that this excellence, for all its genuine virtue, was strategically irrelevant the moment it encountered an opponent who had learned to manufacture adequacy at rates that made excellence superfluous. The American factories that built the 250,000 artillery pieces are mostly gone now, converted back to civilian production or demolished entirely, their contributions measured not in monuments, but in the simple fact of victory. The assembly line workers who built the guns, the women who learned to weld in 8 weeks, the men who operated stamping presses without understanding ballistics, the teenagers who painted serial numbers on barrels, returned to ordinary lives without recognition or ceremony. They had not built masterpieces. They had built enough, and enough turned out to be everything. The lesson, if there is one, resides not in the superiority of one system over another, but in the recognition that modern war had fundamentally changed its nature. The age when conflicts could be decided by superior craftsmanship, by individual excellence, by the quality of a nation's finest achievements, had ended somewhere in the Industrial Revolution, and was finally buried beneath the material realities of 1945. What emerged in its place was something unprecedented, the recognition that in total war, the ability to produce adequate weapons in overwhelming quantity outweighed every other consideration. Skill mattered. Training mattered. Courage and will and tactical brilliance all mattered. But none of them mattered as much as the simple, brutal arithmetic of industrial capacity mobilized for destruction. The German engineers who survived the war found work rebuilding their country, their skills redirected toward reconstruction rather than armament. Some achieved notable success. Others drank themselves into early graves, unable to reconcile the memory of their perfect guns with the reality of their perfect uselessness. The American workers transitioned back to building automobiles and refrigerators, the same assembly lines that had produced 155mm howitzers, now stamping out Chevrolets and Frigidaires. The factories themselves remembered nothing, cared nothing, their machinery, as indifferent to peace as it had been to war, ready to build whatever the next order demanded with the same inexhaustible efficiency. In the end, perhaps the artillery pieces themselves, those 5,000 German masterworks and 250,000 American industrials, serve as the truest monuments. Not to any particular nation's superiority, but to the transformation of warfare into an industrial process, a change as profound and irreversible as the shift from agriculture to manufacturing. The world that existed before this transformation, where craftsmen built individual weapons of surpassing quality, where skill and tradition determined military power, where excellence mattered more than volume, that world ended decisively, finally buried beneath an avalanche of steel that flowed from factories that never rested, never slowed, never stopped building until victory was achieved through the simple expedient of producing more than any enemy could destroy. The guns themselves are mostly scrapped now, melted down, and reborn as bridges, automobiles, skyscrapers. But the lesson they taught endures, that democracy, with all its inefficiencies and compromises, possessed one overwhelming advantage in industrial war. It could ask its citizens to work rather than command them, could mobilize voluntary effort on scales that coercion could never match, could transform ordinary people into an industrial force that buried aristocratic excellence beneath the accumulated weight of adequate mass production. The assembly line, it turned out, was not just an economic innovation, but a military revolution, one that made individual excellence obsolete and collective effort supreme. This was the truth that 250,000 artillery pieces taught to 5,000 masterworks, that in the mathematics of industrial war, enough is always superior to perfect, and plenty will always defeat precision when the battle is measured not in shots, but in tonnage, not in quality, but in overwhelming, inexhaustible, democratically manufactured abundance.